Deep within the hallowed halls of the Kubinka Tank Museum, a titan rests. It draws pilgrims from every corner of the globe, a steel behemoth frozen in time, yet still radiating an undeniable, raw power. 68 tons of solid steel, 12 machine guns, a formidable 130mm naval cannon, and armor plate 350 millimeters thick at its most vulnerable points. This is the IS-7, the heaviest, most potent tank ever conceived within the Soviet Union. A machine engineered to cleave through the armor of any German tank from a staggering distance of 2 kilometers. Yet, paradoxically, it never once rolled into battle. This is the untold saga of how Soviet engineers forged a true monster, a war machine decades ahead of its time, and why the military high command, in a chilling twist of fate, ultimately recoiled from its own creation. As spring blossomed in 1945, Soviet tank columns surged relentlessly towards Berlin. The legendary T-34s and the formidable heavy IS tanks systematically ground down the remnants of German resistance. But even amidst the triumph, the strategic minds of the command were already gazing into the future. Battlefield intelligence revealed the terrifying emergence of German Jagdtigers and King Tigers, their advanced armor proving stubbornly resilient even against the most powerful guns of the Soviet heavy tanks. A stark realization dawned. A fundamentally new machine was imperative, one capable of absolute dominance on any future battlefield should another great war erupt. By June of that same year, a select group of designers convened at the Kirov plant in Leningrad. Their leader was Nikolai Fyodorovich Shashmurin, a man already celebrated for his groundbreaking work on the KV and IS series heavy tanks. Now, however, he faced a challenge of an entirely different magnitude. The mandate was clear: create a vehicle that could withstand a direct hit from any existing tank gun, while simultaneously possessing the firepower to annihilate any enemy armored vehicle at extreme ranges. The project was given the factory designation Object 260. Shashmurin understood that simply piling on more armor was not the answer. Such a tank would become an immobile, unwielder. Designers chose a radically different path. They focused instead on the revolutionary concept of rational angles for the armor plating. The front of the hull adopted a distinctive, aggressive profile, which tank crews would later affectionately nickname the pike nose. The upper frontal plate was angled at an astonishing 65 degrees from the vertical, creating an effective armor thickness that was nothing short of monstrous. An incoming shell, striking such an incline, would not penetrate but instead ricochet, losing the vast majority of its destructive energy. Calculations confirmed their audacious design. The frontal projection of this new tank could withstand a direct hit from a 128mm shell fired by a German Jagdtiger from over a kilometer away. This was an almost unbelievable feat, considering the Jagdtiger's gun was widely regarded as the most potent anti-tank weapon of the Second World War. No series-produced tank of that era could boast such an unparalleled level of protection. But Shashmurin's vision did not stop at the frontal armor. The hull sides also received innovative, sloped armor, further enhancing the tank's impenetrable aura. Within the steel, armor plates were positioned at radical angles, a solution absolutely unprecedented for its era. Even the formidable German Tiger II, a marvel of engineering, boasted armor of only 80 millimeters, while the Soviet IS-2, a contemporary, carried even less. This new machine was conceived to be virtually invulnerable, capable of withstanding assaults from any direction. The turret itself represented a distinct masterpiece of defensive engineering. Its frontal section measured a staggering 240 millimeters thick, while the gun's mantlet, a critical point of vulnerability on most tanks, reached an astonishing 350 millimeters of cast steel. With such formidable parameters, no existing anti-tank weapon could reliably guarantee a decisive strike against the vehicle's forward projection. Soviet engineers had, in essence, forged a mobile bunker, a rolling fortress designed to absorb the sustained bombardment of an entire battery of anti-tank artillery. This immense protective capability, however, inevitably led to a profound increase in mass. Early calculations revealed the tank would tip the scales at over 60 tons, presenting severe challenges to both its agility on the battlefield and its strategic transportation. The vast majority of bridges across Europe would simply buckle under the monumental weight of such a machine, and existing railway platforms would demand extensive, costly modernization. Yet the designers stood firm. They made a clear, uncompromising choice. Overwhelming firepower and impenetrable protection were deemed far more crucial than the logistical complexities they would undoubtedly face. The crucible of war had etched a brutal lesson into their minds. It was unequivocally better to possess a handful of seemingly invulnerable machines than hundreds of vulnerable ones, destined for swift destruction. By the autumn of 1945, the project began to coalesce into concrete form. On the expansive drafting boards of the Kirov plant, the nascent contours of a machine emerged, a vehicle destined to become the undisputed apex of Soviet heavy tank construction. Years of rigorous testing, meticulous refinements, and an unrelenting struggle to shed every possible kilogram still lay ahead. But even then, amidst the rustle of blueprints and the hum of ambition, it was profoundly clear that a dream of unparalleled significance was being born. Once the foundational concept of its armor was firmly established, the engineers faced an equally daunting task. A machine weighing nearly 70 tons could not merely crawl across the battlefield. It had to maneuver with surprising swiftness, conquer formidable obstacles, and achieve speeds comparable to far lighter medium tanks. This demanded a fundamentally new and revolutionary running gear. The engineers at the Kirov plant responded with a genuine technological breakthrough. For the first time in the annals of Soviet tank construction, this new heavy tank was fitted with tracks featuring rubber metallic hinges. Up until this point, every domestic tank had relied on solid, all-metal track links, a design that produced a deafening metallic clatter during movement and suffered from rapid wear and tear. The innovative new construction promised a dramatic reduction in operational noise and a significant extension of the track's service life. Each individual track link connected to its neighbor with a single, robust pin, securely fixed by bolts, a thoughtful detail that vastly simplified field repairs and the replacement of damaged sections, a critical advantage in the chaos of combat. Along each side of the hull, 7 large-diameter road wheels were precisely positioned. These wheels themselves incorporated metal cord tires with internal shock absorption, a sophisticated design akin to those employed on certain German tanks from the infamous Cat family. This advanced solution served to dampen vibrations, enhancing both the crew's endurance and the longevity of the road wheel's outer surfaces. An intricate ballet of engineering designed to keep this colossal titan moving relentlessly across any terrain. The unmistakable clang of metal on metal, a rhythmic symphony of raw power, heralded its approach. Each road wheel, a testament to ingenious engineering, rested upon an individual balancer, meticulously linked to a robust torsion bar. Further dampening the brutal realities of the battlefield, supplementary hydraulic shock absorbers ensured a ride of surprising fluidity, even across the most unforgiving, broken terrain. Particular admiration must be reserved for the bump stops, fashioned as coiled helical springs. These precisely calibrated components deftly restricted the vertical travel of the balancers, preventing violent collisions between road wheels and the hull. even when confronting formidable obstacles. Track tension, a critical element for sustained operation, was managed with remarkable simplicity. A single hexagonal screw. Its rotation, clockwise or counterclockwise, allowed for swift, on-the-spot adjustments to sagging tracks, a feature immensely valued by field mechanics. The system was a marvel of robust reliability, earning the unwavering appreciation of the military strategists who relied upon it. Yet, if the running gear inspired genuine awe with its meticulous design, the choices made by the engineers regarding auxiliary armament continue to ignite fervent debate among historians. This particular machine, known as the IS-7, mounted an almost bewildering number of machine guns. It was as if the designers had resolved to transform a tank into a mobile fortress, capable of unleashing a torrent of fire in every conceivable direction simultaneously. Positioned on each side of the hull's forward section, two stationary bow machine guns, RP-46 models, chambered in 7.62 mm, were permanently mounted. The formidable task of operating these weapons fell to the driver. To aim them horizontally, he was compelled to pivot the entire tank, a cumbersome dance of steel and brute force. Vertical aiming, an even more audacious feat, was achieved through the improbable manipulation of the accelerator and brake pedals. This transformed the act of firing into a veritable circus performance. One can only imagine the sheer delight experienced by the crew within, as their driver, with a mischievous grin, attempted to pepper a distant target with bursts of machine gun fire. These machine guns were ensconced within formidable armored shrouds, their ammunition meticulously stored in dedicated compartments and fed into the weapons via intricate chutes. Spent cartridge belts were ejected through an aperture positioned above, while expended casings cascaded through lower slots. This entire system operated with a surprising degree of autonomy, requiring no direct intervention from other crew members. But the designers, it seemed, believed 4 bow machine guns were simply insufficient. Thus, on the hull's stern, 2 additional RP-46 machine guns emerged, pointed menacingly backward. This audacious arrangement allowed the tank to unleash suppressing fire upon enemy infantry attempting to flank its rear, all without the necessity of traversing the main turret. Even the turret itself bore a pair of RP-46 machine guns of the same caliber, strategically offset to accommodate crucial ammunition boxes. Spent casings and links were neatly collected in small, dedicated metal containers. However, delivering accurate, aimed fire from these turret-mounted weapons proved virtually impossible. The only remotely functional method involved the commander rotating his cupola, peering backward, identifying the approximate trajectory by tracer fire, and then bellowing instructions to the loader, urging him to fine-tune the turret's traverse. The effectiveness of such a convoluted system was, to put it mildly, highly questionable. Yet, the ammunition suppliers, one can safely assume, were undoubtedly pleased. Crowning this magnificent, if somewhat paradoxical, display of firepower was the formidable presence of a large-caliber main gun. It stood as a stark declaration, a testament to an engineering philosophy that embraced both brilliant innovation and an almost obsessive desire for overwhelming, all-encompassing destructive capability, even when practicality seemed to take a distant second place. A fortress on tracks, designed for ultimate protection, yet its most vital weapon left its commander utterly exposed. High atop the turret, a 14.5 mm KPVT anti-aircraft machine gun stood mounted on a pedestal so massive, so unwieldy, that the commander himself could not operate it from within the armored confines of the turret. Instead, he was forced to clamber out, standing precariously on the stern, a lone figure silhouetted against the sky, completely vulnerable to enemy fire. This egregious design flaw stood in stark contradiction to every principle of crew protection. principles so meticulously adhered to in the very genesis of the tank's formidable armor. Beneath the heavy steel, the tank carried an immense arsenal. Approximately 2,500 rounds of 7.62 mm ammunition, alongside some 400 rounds for its heavy machine guns. Transporting such a vast quantity of ordnance was not only a logistical burden, but also raised serious questions about its practical utility. Later, during rigorous testing, engineers conceded that at least 5 of these machine guns could have been painlessly removed, and the machine would have benefited immensely from the reduction in weight and complexity. Along the hull's flanks, hinged panels concealed various pieces of essential equipment. Tucked away within these compartments were the inflatable fuel tanks, crafted from rubberized fabric, resembling oversized canvas bags. This concept, ingenious in its simplicity, had been borrowed from earlier designs where external fuel reservoirs were rigidly bolted directly to the hull. These soft tanks, however, proved far more compact and convenient for storage, a clever adaptation. Yet accessing these compartments presented its own challenges. The panels had to be manually opened, many 2 or even 3 crew members to wrestle the cover back into place. It was a detail that spoke volumes about the constant trade-offs between innovation and practical battlefield realities. Forging powerful armor and a robust suspension system represented only half the monumental task. The true crucible for the designers lay in confronting the ultimate challenge inherent in all super-heavy tanks: finding an engine capable of moving this steel behemoth and, crucially, endowing it with respectable mobility on the battlefield. The German Maus, a Titan weighing 188 tons, could barely crawl at a speed of 20 kilometers per hour, its colossal power plant perpetually plagued by overheating. Soviet engineers, acutely aware of these foreign failures, were determined not to repeat them. Their search led them to the M50T engine, a power unit originally conceived for torpedo boats. This formidable 12-cylinder, liquid-cooled diesel machine delivered an astonishing 1,500 horsepower, a figure almost beyond belief for its era. No other serial production tank engine of that period could even begin to rival its sheer output. To put this into perspective, the legendary T-34's engine developed around 500 horsepower, while the heavy IS-2 tank's power plant mustered a mere 520. The engine's maritime origins, while granting it immense power, simultaneously introduced significant complexities in its integration. The M50T consumed an enormous volume of space within the tank's stern, demanding equally potent cooling systems. The designers meticulously arranged radiators and fans to ensure a relentless, maximum flow of air through the engine compartment. On the upper surface of the stern, armored caps emerged, serving as access points for filling coolant, engine oil, and transmission fluid. Yet a far more serious problem arose regarding access for maintenance hatches in its engine compartment. There were no large, hinged covers that could be easily opened. This oversight would prove to be a profound vulnerability, transforming routine servicing into an elaborate, time-consuming ordeal, a critical weakness in an otherwise formidable war machine. The very heart of the tank, its most vital organ, remained stubbornly out of reach, a silent testament to the compromises inherent in pushing the boundaries of engineering. No small circular hatches, none of the familiar access points seen on the T-34 or the KV series. To reach the engine, mechanics faced a monumental task. They had to meticulously unfasten an array of colossal bolts encircling the entire rear panel. Only then, with the aid of a heavy-duty crane, could the entire upper section of the stern be painstakingly lifted away. This procedure was not merely laborious, it was an engineering spectacle, demanding specialized equipment and an almost impossible investment of time, effectively rendering any field repairs a distant, unattainable dream. The designers, acutely aware of this profound limitation, had always intended to refine the structure, should the formidable machine ever transition into serial production. Yet, for this prototype, the decision was made to prioritize the rigorous testing of its core systems, leaving the intricate dance of engine access for a later, perhaps never-to-come, stage. Despite this glaring practical hurdle, the results of the initial road tests shattered every preconceived notion, defying all expectations. This metallic leviathan, boasting a combat weight exceeding 68 tons, achieved an astonishing speed of 60 kilometers per hour on paved roads. Such velocity was nothing short of revolutionary for a vehicle of its class, rivaling the performance metrics of far lighter, medium tanks. Engineers, witnessing this behemoth accelerate, must have felt a surge of disbelief, a quiet awe at the sheer power unleashed. The transmission system, a complex marvel of its own, also commanded particular scrutiny. Early iterations featured a 6-speed gearbox, a robust but somewhat constrained design. However, this was swiftly superseded by an 8-speed variant, a crucial upgrade that delivered not only smoother acceleration, but also vastly improved adaptability across a diverse range of terrains. The shift lever, surprisingly intuitive, guided the driver through a progressive ascent, from first gear steadily upwards, a familiar rhythm for any seasoned tanker. Yet a separate lever, dedicated solely to directional control, harbored a peculiar logic, a quirk that could easily disorient the uninitiated. Pushing it forward engaged reverse, while pulling it back initiated forward motion. This counterintuitive design, a silent testament to the unique engineering philosophies of the era, demanded a complete reorientation of muscle memory, a mental recalibration for every driver stepping into the cockpit. Now to the very heart of its destructive potential, the main caliber. The designers harbored no illusions. For a tank destined to spearhead breakthroughs, an armament capable of obliterating any fortification and neutralizing enemy armored vehicles at extreme ranges was not just desired, it was absolutely essential. Their choice fell upon the IS-7 cannon, a formidable 130mm weapon, its lineage traceable directly to naval artillery. This formidable heritage imbued it with an inherent power, a legacy of maritime might translated to land warfare. Its barrel alone stretched to an imposing length of almost 7 meters, a colossal conduit for destruction. This immense length was the secret behind the projectile's staggering muzzle velocity, 900 meters per second. The armor-piercing round, weighing a hefty 33 kilograms, possessed the raw kinetic energy to breach the frontal armor of any contemporary tank, even at distances exceeding 2 kilometers. To grasp the sheer magnitude of this capability, one need only consider the renowned German 88mm anti-aircraft gun, a weapon held in high esteem by the Wehrmacht. Its projectile, while potent, typically achieved a muzzle velocity of approximately 800 meters per second, a full 100 meters per second less than the IS-7, and consequently, it significantly lagged in terms of raw penetrating power. The IS-7 was not merely an upgrade, it was a leap into a new echelon of battlefield dominance. The high-explosive fragmentation rounds proved no less devastating. They possessed the sheer force to splinter field fortifications, to shatter pillboxes into mere splinters, and to utterly dismantle lightly armored vehicles with a single, thunderous impact. The battlefield, once defined by static defenses, now faced an existential threat from this mobile, overwhelming firepower. When utilizing its integrated loading mechanism, the gun achieved a respectable rate of fire, 5 rounds per minute. However, should the mechanism fail, or if manual loading became necessary, this rate plummeted dramatically to a mere 1 shot per minute. This initial 5-round burst, a fierce torrent of steel, was only sustained as long as the ready ammunition in the autoloader's conveyor remained. Once that precious reserve was expended, the rate of fire would sharply decline, the agonizing wait for new ammunition to be manually loaded into the mechanism, transforming minutes into an eternity under enemy fire. Beyond this monstrous main gun, the turret was designed to house a formidable array of secondary armaments. A coaxial heavy machine gun, chambered for 14.5mm rounds, was slated for installation, providing a brutal answer to light vehicles and entrenched infantry. Complementing this, two 7.62mm SGMT machine guns were planned, offering a relentless barrage of suppressive fire, ensuring that even the most determined infantry assault would face an unyielding wall of lead. This tank, a paradoxical blend of revolutionary power and practical challenges, represented the cutting edge of its time. It was a testament to ambition, a formidable weapon designed to reshape the very nature of armored warfare, even if its own internal complexities sometimes bordered on the fantastical. Its very existence pushed the boundaries of what was thought possible, a true iron titan of the battlefield. A museum piece, this heavy machine gun appears as though it was hastily remounted for display, its original attachment points conspicuously absent. The planned coaxial machine guns of a smaller caliber are entirely missing, though the precise fittings for their installation remain. This visual incongruity immediately hints at a story of compromises and brutal realities, a stark contrast to the polished image of military might. The main gun's ammunition supply consisted of approximately 30 rounds, each requiring separate loading. Shells and propellant charges, housed in their brass casings, were stored in specialized racks scattered throughout the fighting compartment. This distributed storage scheme was a deliberate design choice, engineered to significantly reduce the catastrophic risk of a full detonation should the armor be breached. Yet, this safety measure came at a steep price, imposing immense physical demands on the loaders. They were forced to meticulously maneuver two heavy, distinct components for every single shot, a grueling process far more complex than handling a single, self-contained cartridge. The internal architecture of the turret, designed for a crew of 4, was a study in paradox. It astonished with its apparent thoughtfulness, yet simultaneously presented its occupants with formidable, unrelenting challenges. The fighting compartment, a cramped steel labyrinth, housed the commander, the gunner, and 2 dedicated loaders. Each individual was assigned a strictly defined space, a precisely allocated segment within this unforgiving metallic shell, where every movement was calculated, every inch precious. The commander's cupola, nestled in the turret's right rear section, offered what could only be described as relatively comfortable working conditions, a rare luxury in such confined spaces. The forward view remained unobstructed, a crucial advantage in the chaos of battle. A surprising, yet essential distance separated the commander from the gunner's back, providing just enough clearance to prevent the commander's knees from painfully pressing against his comrade. This small detail, often overlooked, spoke volumes about the meticulous, if sometimes flawed, design considerations. For battlefield observation, the commander relied on 3 square viewing prisms, strategically positioned around the coup, resulting in a narrower field of view through each. This limitation, while minor, meant a constant, vigilant effort was required to maintain situational awareness. The primary instrument for comprehensive reconnaissance, however, was a rotating periscope, ingeniously integrated into the hatch lid, granting the commander an expansive 360-degree panoramic view of the surrounding terrain. Directly behind the commander's seat, a stack of main gun shells was meticulously stowed. This placement, while efficient for ammunition access, eliminated any possibility of leaning back and finding even a moment's respite during long, arduous marches. Adjacent to the seat, boxes of 14.5mm ammunition were secured, with smaller caliber rounds stored just beyond. It was also here that the control panel for the internal communication system was located, a vital nerve center allowing the commander to issue precise orders to every member of the crew, cutting through the din of battle. An intriguing design peculiarity was the absence of a conventional turret basket. Instead, a unique platform provided the crew with a place to rest their feet. On the museum specimen, the crucial protective railing, designed to shield limbs from the crushing gears of the turret traverse mechanism, is conspicuously missing. This absence sparks a quiet debate. Perhaps it was temporarily removed for inspection, or perhaps its installation was simply deferred, a detail intended for later inclusion once serial production commenced. Tank crews, with their grim humor, affectionately nicknamed the rotating turret mechanism the Monster. They claimed it possessed an uncanny ability to snatch various objects during its turns, swallowing them into its metallic maw, never to be seen again. Often, the victims were small yet critical items: a map, a codebook, a radio handset. But occasionally, the Monster would claim a more significant prize, ensnaring an unlucky crewman by an exposed limb, a chilling reminder of the ever-present danger within the machine. The loaders' positions, situated on either side of this rotating leviathan, placed them in constant perilous proximity to its hungry gears. Within the steel heart of the tank, the recoiling components of the main gun dominated the fighting compartment, their intricate mechanisms nearly identical across different models. Though the original crew seats have long been removed from the museum exhibit, the robust ammunition stowage cradles remain, occupying virtually every available inch of the confined space. From this vantage, the severe incline of the side armor plates becomes strikingly apparent, with the primary shell racks positioned directly above them. The claustrophobia inside was absolute, forcing the loaders to operate in conditions more akin to a submerged submarine than a combat vehicle. The true marvel of this cramped fighting compartment, the crowning achievement of its design, was the semi-automatic loading mechanism with its integrated conveyor system. This ingenious device was engineered to significantly alleviate the crew's arduous task during sustained firing. At any given moment, the mechanism held a formidable payload: 7 shells positioned in its upper section, and 6 propellant charges, complete with their casings, nestled in the lower part. The moment a round was fired, the breech would snap open automatically. The spent casing, ejected with force, would strike a small metallic chute below, deflecting it efficiently to the side and out of the way. The intricate ballet of loading began with the loader. He would maneuver the next shell, guiding it onto the conveyor, which then began its measured journey towards the gun's breech. Immediately after, the same precise operation was repeated with a propellant charge and its casing. As both critical components drew near the breech, the conveyor's tray would smoothly ascend, rising parallel to the hull's roof, perfectly aligning the ammunition with the gun's loading line. Yet, the conveyor alone could not complete the final, critical push. To seat the projectile and charge fully into the firing chamber, an electric rammer engaged, delivering the final, decisive thrust. Should this sophisticated loading mechanism falter, a grim reality for any tank crew in the crucible of combat, they were forced to revert to manual operation. This demanded immense physical exertion. The loaders would seize specialized T-shaped manual rammers, using sheer muscle to shove the heavy shell and then the propellant charge into the breech. Only then, with the breech firmly closed, was the formidable weapon ready to unleash its destructive power. This painstaking procedure had to be repeated until all 6 rounds within the mechanism, plus the one initially loaded, were expended. The entire conveyor system then required a complete, time-consuming reload. Adding to the loader's immense challenge was the inconvenient placement of some ammunition racks. A portion of the shells were strategically buried near the gunner's seat. To retrieve these vital rounds, the gunner himself had to partially lift from his position. The designers, anticipating this predicament, incorporated a specific indentation in the backrest of his seat, a small concession meant to allow the loader a sliver of access to the needed ammunition. Still, it remained an arrangement of profound awkwardness. It is highly probable that in the brutal reality of battle, crews would prioritize expending the readily available rounds from the mechanism, reserving the laborious task of replenishing the conveyor for fleeting moments of reprieve during lulls in the fighting. The gunner station, situated to the left of the main gun, was another testament to the tank's relentless pursuit of compact efficiency. It was a space defined by its severe constriction. The manual traverse and elevation controls for aiming were positioned directly before the gunner's chest, severely limiting legroom and overall movement. Even a person of below-average height would find themselves in a state of perpetual discomfort. The primary aiming sight was mounted in such a way that the gunner had to press his forehead directly against it to engage targets. This same sight was ingeniously utilized for firing the coaxial machine guns, a testament to its versatility. The overall fire control system, though decades old, would feel remarkably familiar in its fundamental principles to a modern tank crewman, a stark reminder of the enduring challenges and timeless solutions in armored warfare. The hand grips, equipped with their intricate triggers, offered precise command over the entire aiming system. Vertical targeting was achieved by tilting these grips forward or backward. Horizontal traverse, in contrast, came from rotating the entire mechanism right or left. This method represented a radical departure from most Soviet and Western tanks of the era, where horizontal aiming often mimicked the more familiar steering of a car. To the gunner's left, a manual turret traverse mechanism stood ready, a silent sentinel against the potential failure of the electric motor. Two observation devices, similar to those afforded the commander, offered the gunner a constricted view of the world outside. A periscope for all-around observation, a crucial element for comprehensive situational awareness, is conspicuously absent from this museum specimen. Yet, its mounting point remains, a ghost of a planned upgrade, suggesting this vital piece of equipment was destined for installation on production models. The control compartment, positioned in the hull's forward section, was the isolated domain of the driver-mechanic, the sole crew member separated from the rest within the combat compartment. Access to his solitary post was granted through an individual hatch in the frontal armor, a massive slab of steel that slid sideways along its guides. Once inside, the workspace itself gave an impression of thoughtful design, its layout simple yet remarkably efficient. The seat adjusted for height, allowing it to conform to the specific dimensions of any tank crewman. The cushion, though, was notoriously thin, a detail that promised considerable discomfort during extended marches. Experienced mechanics, no doubt, carried their own extra padding, a small act of rebellion against the bone-jarring reality of cross-country movement. Despite this, the overall ergonomics were largely commendable. 7 distinct observation devices provided the driver with an unparalleled view. 3 periscopes set into the hull roof on either side of the hatch. 1 central periscope integrated into the hatch cover itself, and 3 additional prisms embedded in the frontal plate. This optical array delivered exceptional situational awareness, a critical advantage when maneuvering a multi-ton behemoth under fire. In less hostile environments, the driver could even operate the tank with his hatch slightly ajar, his head exposed to the open air, a luxury utterly forbidden in the crucible of combat. To the left of the driver's seat, a dedicated stowage compartment held 7.62 mm machine gun ammunition. Nearby, a shelf awaited the battery banks, which are absent from this museum piece, Their unfamiliar sight for Soviet vehicles of that period offered no revolutionary departures. Its only peculiar feature was the speedometer, positioned unusually on the far right edge, a layout previously seen only in the T-series tanks. The main power switch, an essential control, was placed directly between the driver's legs, an ergonomic choice that presented its own unique challenges. The starter button lay just before the knees, within easy reach. The horn, however, deserved a moment of quiet reflection. On a machine built for war, a horn seemed almost a comical extravagance. Yet its purpose was undeniably practical, an indispensable tool for maintaining formation in convoys or navigating through populated areas. To the right of the seat, a machine's complex internal life. Every detail, from the unique aiming system to the driver's uncomfortable cushion, speaks to the intricate balance between innovation and practicality, a testament to the relentless pursuit of military advantage within the confines of human endurance. The biting winds of the Russian winter could plunge temperatures far below freezing, often reaching a brutal 30 degrees Celsius. In such an unforgiving environment, the very heart of a tank, its engine, could seize in a frigid grip, refusing to ignite. A conventional electric starter, strained by the dense, cold oil and stiffened metal, often proved utterly insufficient. This was a critical vulnerability, a potential death sentence on the battlefield or during a crucial maneuver. Yet the IS-7 possessed a formidable countermeasure, a sophisticated compressed air system designed for engine ignition. When the electric starter faltered, a seasoned mechanic would open a specific valve. A sudden, powerful hiss of compressed air would surge into the engine's cylinders, forcing the massive crankshaft to turn. With each powerful rotation, the engine would slowly, then rapidly, gain momentum, until finally, with a thundering roar, it would catch, splutter, and then settle into a steady, life-giving rumble. This ingenious system was a testament to robust engineering, a lifeline that repeatedly rescued tank crews from desperate situations, ensuring operational readiness even in the most extreme conditions. Operating the formidable IS-7 was an exercise in tactile command. Control was primarily achieved through two imposing levers, each serving a dual purpose: steering the 70-ton behemoth and applying its brakes. A traditional brake pedal was conspicuously absent. To secure the tank in place, locking buttons situated on the upper portion of these very levers would engage, transforming them into a powerful parking brake. While this arrangement was considered advanced for its era, offering a simplified interface compared to its predecessors, it presented a specific limitation. The IS-7 could not perform a neutral steer, a maneuver that allowed tanks with independent side clutches to pivot in place. Despite this, the overall ease of handling marked a significant improvement over earlier generations of heavy tanks, making it more accessible to its crews. Within the cramped, functional confines of the crew compartment, every inch was optimized for combat efficiency. Several fire extinguishers were strategically mounted, ready for immediate deployment. A telescopic mechanism stood by, designed to assist in the arduous task of opening the heavy, armored hatch. The manual throttle, a direct link between the driver's hand and the engine's power, offered precise control. Hidden within specialized compartments, spare instrument lamps, individual first aid kits, and other vital expeditionary sundries were meticulously stored, reflecting a profound attention to detail and preparedness. Behind the crew's positions, ammunition boxes for the coaxial machine guns were securely stowed, a constant reminder of the tank's devastating firepower. By 1948, 6 prototypes of the IS-7 had been meticulously constructed. Each underwent an exhaustive regimen of factory and state trials, pushing the boundaries of its design. The results were nothing short of extraordinary. Across every critical metric, mobility, protection, and sheer firepower, These machines demonstrated truly outstanding characteristics, setting new benchmarks for heavy tank design. The path to mass production seemed irrevocably clear, a new era of armored dominance on the horizon. But then, a profound and unexpected decision emanated from the highest echelons of military command. Despite its undeniable superiority, the IS-7 was not destined for the production lines. In a parallel development, another heavy tank, designated the IS-8 and later famously known as the T-10, was also undergoing evaluation. This rival machine, by almost every objective measure, lagged behind the IS-7. Its armor was notably thinner, its main gun possessed less formidable stopping power, and its top speed was demonstrably lower. But the IS-8 possessed one overwhelming, irrefutable advantage: its manufacturing cost and operational simplicity. The IS-7 was a marvel of engineering, but its construction demanded specialized equipment, a supply of rare and exotic materials, and the meticulous craftsmanship of highly skilled laborers. Its formidable 12-cylinder marine diesel engine, a powerhouse of unparalleled performance, alone cost as much as several conventional tank engines combined. The automatic loading mechanism, while innovative, was notoriously complex and prone to delicate operation, a potential liability in the chaos of battle. Furthermore, field repairs were rendered virtually impossible due to the complete absence of access hatches to the engine compartment, forcing any serious maintenance to be conducted in specialized depots far from the front lines. The logistical implications of deploying the IS-7 were equally staggering. Weighing nearly 70 tons, its sheer mass created an unprecedented transportation nightmare. The vast majority of existing railway platforms and crucial bridge infrastructure simply could not withstand such an immense load, severely limiting its strategic deployment and tactical flexibility. In stark contrast, the IS-8, weighing a more manageable 49 tons, presented a far more practical solution. It incorporated proven, readily available components and assemblies, simplifying both its production and maintenance. Crucially, it could be easily repaired by its own crew in the field, a vital factor for sustained combat operations. Its lighter weight also meant it could be transported using standard logistical infrastructure, eliminating the colossal bottlenecks that would have plagued the IS-7. In the grim crucible of the post-war economy, as the nation grappled with the monumental task of rebuilding from the catastrophic devastation, the factor of cost proved utterly decisive. Generals, faced with the stark realities of shattered infrastructure and depleted resources, made a pragmatic, if agonizing, calculation. The extraordinary performance of the IS-7, while breathtaking, could not outweigh the crushing burden of its production, maintenance, and logistical footprint. The IS-7, a titan of engineering prowess, a testament to what was technically achievable, ultimately succumbed not to a flaw in its design or performance, but to the harsh economic realities of its time. It remains a powerful symbol of ambition, a dream of unparalleled armored might, sacrificed on the altar of practicality and the pressing need for a nation to rebuild. The roar of its mighty engine, once a promise of dominance, faded into the annals of what might have been, overshadowed by the more humble, yet ultimately victorious, practicality of its successor. Military doctrine often whispers a hard-won truth. 3 reliable tanks will always outlast and outperform a single, magnificent, yet temperamental marvel. This philosophy, forged in the crucible of conflict, often dictated the fate of ambitious engineering. From the factories, a mere 6 prototypes of the first experimentatious vision, pushing the boundaries of what was then possible. But the program, plagued by its inherent complexities and the relentless demands for battlefield practicality, was ultimately abandoned. Most of these engineering ambitions met a stark end, consigned to the scrapyard's hungry maw, or reduced to mere targets on desolate firing ranges. Yet, against all odds, a single example defied the inevitable. A lone survivor from a visionary yet ultimately flawed design. Today, it stands within the hallowed halls of the Kubinka Tank Museum, a silent testament to a forgotten era. There, it rests not alone, but beside its colossal German adversary, the infamous Maus, a behemoth of steel that shared a similar fate, a testament to the era's obsession with overwhelming yet often impractical power. A stark, metal-clad reminder that true strength often lies not in audacious complexity, but in unwavering, dependable resolve.